All right, so in this video, we're going to be talking about laws of exponents again, but this is going to be an alternative approach to rational exponents. So hopefully if the other video was confusing, this one might clear it up, or maybe it'll just add upon your new knowledge. So let's go ahead and get into it. So when you have a problem that looks like this one does, you can write it in terms of this. Because this exponent is 1, that's going to be our numerator. And then we're taking the nth root, so that becomes our denominator. But because then we're taking the mth root of this entire quantity, then we get to turn that into a fraction and make it an exponent. That's where this 1 over m comes from. And then when you put it all together, you end up with a to the 1 over mn, which is a lot simpler in a way than doing this whole radical business. It looks a lot simpler. So let's try an example. Third root of the fifth root of 2 to the first, or just plain old 2. So that's like saying 2 to the 1/5, because that's this inner radical. That's right here. But then because I have another radical, I'm going to again raise it to the 1/3, because saying a base, that's a square base. It's just a square for visual effect. I have a base to the 1/3 power. That's like saying the third root of that same base. So hopefully that makes a little sense. And then you can further simplify this like it is up here to just 2 to the 1 over 5 times 3, or 2 to the 1 over 15. So here's another one, and this is where it kind of gets a little more complicated, but not necessarily. Here I have an exponent of c within the first radical. So this c is going to show up in my first fraction. It's going to be the numerator. And again, because we're taking the nth root, that becomes the denominator. Now this 1 over m comes from the outside radical. And there's a 1 on the numerator because this whole expression underneath that outside radical is already represented here. So I don't need to take this, and you don't need to worry about the c again. It's just I'm going to have a 1. So remember like what I said before when I had the little square, which I happen to really like, so I hope you like it too. And I have the 1 m that's like the mth root, that same square. So that's essentially what we're doing here. Mth root is this outside right here. And this whole inside is like our square. So that's why I can have like the square to the 1 over m. And again, if you simplify it, you're going to end up with a to the power of c over mn, which is just these two exponents multiplied together. So let's try an example. If I had the third root of the fourth root of 5 squared, that's like saying 5 to the 2 over 4, all raised to 1 over 3. And that's going to leave you with 5 2 over 12. 5 raised to the 2 twelfths, which can be simplified to 5 to the 1/6. Again, you can make it even more complicated by adding another radical to the outside. And so adding another radical to the outside is kind of really just going to be adding another exponent. You're just going to be raising your expression to another power. So then we can simplify it down to this. So a to the c over p times m times n, because we're really just multiplying all of these exponents together, and it becomes all one big exponent. So now let's try an example. Let's have for the fourth root of the fifth root of the 6th root of 3 squared. So let's change this innermost radical is going to become 3 to the 2 over 6, because our c stays the same. Here's our c, that becomes our numerator. And then our nth root, that n becomes our denominator. That's what we have here. But that is all going to be raised to the, we have that 5 to the 1 over 5th power. That's like saying this orange is our square, and here's our square, so there's our other exponent. And then finally, you have this 4, so it's like saying all of this raised to the 1/4. This is going to become 3 to the 2/6 times 1/5 times 1/4 power, which is going to be 3 to the 2 over 1/25th power, which of course can be simplified to 3 2 over 60. Oh, sorry, 1 over 60. And you can solve that exponent out, but I'm just going to leave it how it is.